I saw you post about your grandfather, Thomas. You had some incredible things to say about him. How I think he slept in a bar booth in Detroit for throughout his teenage years. Tell me about Thomas, and just tell me about how that story of grit and kind of innovation shaped your own life and your journey to starting Aurelius.
Yeah, for sure. In a lot of ways, my grandfather raised me. So I grew up, didn't have a dad really. And so, just growing up around him was really, really great because he's just kind of like, I think a lot of the silent generation people are kind of like very, especially men are like very solemn and silent. A lot of the time they don't, necessarily express too much emotion. But, when it came to learning how to do hard work and do hard things, even when when the deck's kind of stacked against you, that's something that I really, really took away from him. So that experience, especially during my formative years, was great. Where my grandfather, Thomas, grew up in Detroit. Most of his formative years, he was sleeping like in a bar booth. So like basically this is around like when World War II is happening in Detroit and like people would be, soldiers and sailors would be home in a bar, I think on Joy Road off of 96 on the entryway to Detroit, maybe 10 minutes outside of the downtown area. I hope that's right. I think that's the crossroads. But, he'd have to wait until like 2 a.m. to go to sleep because like people would just be like drinking and stuff. It was just crazy. So his life's crazy. He ran a paper route in Detroit from when he was 6 to when he was 8, I believe 18, maybe 17, 18, 17, and was able to save all the money to go to University of Detroit. We studied chemistry, he did a few other things. He joined the Army, and then he went and worked at Ford for 36 years, maybe 40 years, something like that. Ended up being the chief chemist there. And so he's done a ton of glass and crystal work. So yeah, just growing up with someone like that, kind of like raising you was just amazing. Great experience. So yeah, would highly recommend having a dope grandpa that's hardcore.
What do you think your grandfather would be working on if he was alive today?
Oh, what would he be working on right now? Oh, dude, he'd be like 92. I don't know how much he'd be working. I think what he would
no,
be
sure.
doing
Say he was still in his prime. Say he was in his 30s, 40s today.
Okay,
He was
gotcha.
he was at the cutting edge
for
back
sure.
then.
What would he be doing? Oh, he'd probably be working on physical chemistry, something technical. He wasn't a great student. He was just a really good experimentalist. So he really liked to actually try things out and build stuff. But yeah, he would probably, I don't know. A lot of his frame of reference was around being a company man. He stayed at the same company for 36 years. That would definitely change. He probably would want to make a lot of money. Maybe he would do CS. I don't know. But then also CS is kind of, I don't know if you've seen the unemployment rates for new grads, but it's pretty heinous out there. So I don't know if that's the move anymore. So I think I don't know if my grandfather was so much compelled by he definitely enjoyed working on like cutting edge new technologies, but I don't know if he was so much compelled by that rather than compelled to work as hard as he can for the best life that he can provide for himself and his family. And I think that was really what compelled him mostly.
Timeless principles.
Exactly.
Listen, let's talk about what you're building at Aurelius Systems. Walk me through your flagship product. I got to see it in Detroit last week. It was a real joy. Walk us through the technology, how it works, what it's trying to accomplish.
Yeah, definitely. So what we do at Aurelius Systems is we make edge-deployed, lightweight, small-scale laser weapon systems, where right now there are laser weapons deployed by Lockheed and Northrop. They're generally very large and expensive. Like a Helios 60-kilowatt system is tens of thousands of pounds. These things are tens of millions, if not below $100 million per system. They're really cool. You can shoot a missile down from like 20 miles away. You can cut a plane in half from like 10 miles away. They're awesome. I used to work on some of the subsystems to support them. But, against drones like Group 1, Group 2 UAS, so small quadcopters or like smaller plane size drones, as you might have talked about this on your podcast already with other guests, is like those systems. The main benefit of those systems for the enemy is that they are mass deployable, they are cheap, they can be built by like your grandma in a basement really quickly. And so what we do right now is we shoot very expensive single-use munitions at them. The promise of directed energy, which is like the PC way of saying laser weapon or microwave weapon, there are microwave systems as well. The promise of directed energy is that you get like basically a no marginal cost to shoot down. It's like the cost of electricity. The electricity in a battery is your ammunition or in a generator. And so you get a 10-cent cost to shoot down, but the capital expenditures on these very large and heavy Lockheed systems are like $50 million. So what do? We want to get the best of both worlds, take mostly commercial off-the-shelf components, use really, really advanced software, use edge-deployed AI systems, very, very power-efficient laser systems where we get into the guts of some of these laser systems to make them a little bit better, and make an auto turret. So that is our first product. It's called the Archimedes. Archimedes of Syracuse is a really famous physician and ancient engineer. When the Romans were sieging Syracuse, he was like in his 70s or 80s, and the king called him up to like help defend the city. And he made two things. One is more famous than the other. The Archimedes lever, where, he's like, give me a lever long enough and I can lift anything, right? So he built that to flip ships in the bay. And then he also built the first directed energy weapon in like 200 BC, where he set a series of mirrors on the city walls and burned ships in the bay. And so that's why we're calling it the Archimedes. So I just little history lesson. You don't look too amused, but we can we can continue to answer the question, Stephen. Sorry, I'm all over the place, but I
love it.
It's
Keep
early,
going.
and I'm just excited to be here. So so that's our first product. Our we have demonstrated for the Navy at the Naval Postgraduate School at a few hundred meters, a shorter range. We go to an Army demonstration at Camp Grayling here very soon, and then there are a couple more in the fall that we'll go to. And the whole goal is to get out to a couple kilometers in effective range. I can't talk much more about like the specs than that, but I think things are going really, really well, and it's really interesting where I think a lot of people are really tuned into advances in AI in terms of like maybe object identification or like language processing, things like that. But mechanical engineers are getting in an AI by doing super advanced control algorithm work that's informed by reinforcement learning or by neural networks in some way. And so that is a really, really interesting kind of edge of technology that we're getting into to make do without millions of dollars in support equipment. You got like $50,000 in support equipment for your weapon system. So how do you differentiate? You get really good at software, I think. I'll shut up.
Say what you can. Yeah. So no, good, all good. Say what you can about how the system actually works on the ground, from the time it detects a threat to the moment that threat is neutralized. What's the key innovations? Obviously, you've been able to shrink these big, huge, expensive lasers down. So just talk me through everything to do with the product.
Yeah, I think one of the things is that those big laser weapon systems from Lockheed or Northrop, they work really well. They're really advanced. They put a lot of power downrange on target at many, many, many kilometers, many, many miles. And I think with the Golden Dome announcement, they'll continue to get funding for that. I know there are a couple of companies kind of in that conglomeration that are going up and trying to do an even bigger laser weapon system, right? They're talking about like suborbital targeting. And so that is something that, to do that, you need to raise kind of a capital cost, or you need to raise an amount of capital that's kind of like you'd be pitching like starting a semiconductor company, kind of, where you're like, I need $100 million to like have a stab at this. So that's very difficult. I think what we do here is what we want to do is see like, what is the like AK-47 version of a laser weapon, where it's like very robust. It is you're mitigating for lower quality hardware, or you're mitigating for like less bespoke custom pieces in the hardware by using really advanced software. And so that's a thesis we have in some way. We have to go to production with our own laser system, which we're really excited to do. We'll start that here soon. And I talked about some of the subsystems. What else did you want to hear about?
Yeah, no, just talk me through actually, when you detect a drone, when you detect kind of an enemy system, just talk me through how it actually works.
Got you. I don't know.
When people hear lasers are. We're all 8-year-old boys when we hear lasers.
Sure.
We're like, tell me more about the laser.
I think 95% of it from first principles is like you take lasers that you can the architecture's figured out. You know, it's not experimental. We don't want to be experimental. We want to be like deployable. So you take lasers that are used in, say, industrial machining, something like that, very high power laser systems. And then instead of focusing the output at like 2 inches away, you're focusing your output at your target distance, which could be 3 miles or something like that. And from a first principles perspective, that part of like the laser destruction is not too complicated. Now, where you want to make advancements is manufacturing the lasers because they can get very expensive. So you want to try and extract cost volume savings on the diodes. Try and find alternative markets that you can sell your lasers into, because in optics you extract a ton. I think more than other parts of the hardware world, you extract a ton of value in selling volume, and so that's where a lot of the advancements are in, dealing with cooling, dealing with electrical efficiency, dealing with actually getting power, drawing down from very high drawdown batteries. We're battery powered. From the beginning, we knew we didn't want to be attached to a generator. You see these systems that are like have to be in like an armored personnel carrier. We don't think that's tenable, so we made the decision to do that pretty early. When we detect a drone that is out in the field that is coming toward a target, we essentially have a series of sensors that range between coarse and fine in terms of detection capability, because you don't want to raw look through the sky actively or passively or whatever, right? Anyone's sensing, that's a very, very hard algorithmic problem to do, and it wastes a lot of compute power. So you want to have a series of sensors that kind of like optimize how much power you're looking at, how much power you're drawing down, how much compute you're drawing down when you want to detect something. And when we detect something, you turn to it, and you have an advanced control system, so it's very quick in the course, and then it is very smooth, and you don't want to wiggle around when you're targeting the system, and then you continue at a very high rep rate to identify, target, track, and destroy that drone. And that's probably as deep into it as I can get right now, unfortunately. Yeah, I'm trying to dance around the rules. I'm trying to make sure I don't mess anything up. So.
Of course. What was the moment you said to yourself, this system needs to be built and I'm going to be the one to build it? Was there like a specific catalyst?
Yeah, so I worked at Coherent for a while, which is a big US laser company. I worked in research and development, building material processing systems in the systems development group. Those systems are very similar to directed energy. And then I did a little bit of work in that area as well, especially as we acquired some directed energy companies, I think, in the early time that I had worked there. From there, I moved into sales, and I ran West Coast component sales, so like diodes, fiber, things like that, all subsystems, amplifiers that would go into some directed energy products on behalf of primes. So I worked in that space a bit, and we knew that you could do this. You could do a small scale, lightweight laser weapon system, but it's not in the incentive or like the business model of some of the larger defense companies to do anything to go and do that. Like we're talking about things that, just the volume that they were looking at, and you would have to go to production and stand up a manufacturing line. That sucks. You would go and do that, and then you would be cannibalizing potentially some of your existing products. There's just this whole innovator's dilemma thing, and things move even slower in defense than in like tech companies. And even this can even happen to tech companies where they don't want to do new innovation. So all this to say, we knew that we could do it. We didn't have anyone that wanted to do it. And also in like 2019, 2020, it wasn't like, I think there obviously, like Anduril, there were companies that were on the cutting edge and people that knew drones were going to be a problem, but it wasn't a mass problem where it is now, where it's very clearly the most salient issue in the DoD is how do you deal with these drones. So I was in my PhD in 23, at the end of 23, beginning of 24, and then it just became apparent that this was the time to go and do this. Everything was taking off. Funding was opening in San Francisco to be able to do this. So I dropped out of my PhD to do this. So yeah, that's it. We're like a year and a half on now. Yeah.
Awesome. When people think of lasers, they might think of, these big static installations like the one you were mentioning, but your system is portable. Just talk me through the reason for that, and how you think it potentially changes warfare going forward, either on the defense or offense side.
Yeah, for sure. I think that if you're in an LTV or a troop carrier or a tank, for example, especially we're talking about the ground vehicle application here, which is one of the earlier ones that we're going after. Like the way that you attack is in a tank, for example, is you suppress and then you move in and fire for the kill. So you move to suppress your target. If it's like a machine gun installation, you can do that, and you can move and acquire around and actually go in and engage your target and destroy them. And the U.S. military operates an extremely aggressive doctrine, whereas say the Russian military is like will try and bait you, like the Ukrainians, into engaging in a fight, pull back, and then pull you into their defensive line. So it's just a different doctrine, and we run an extremely aggressive one compared to most countries. And right now, like 2 or 3 or 4 FPV drones could go fly into like a tank and like blow it up, and that tank could be like an Abrams could be between $8 and $13 million, right? But also, but it's not even that much about the money. I think what it is, especially for our contacts in the DoD, what it is for them is like, how do we get our offensive capability back? How do we actually become effective at destroying targets? Because it's when you're talking about either protecting like American lives in combat, or you're talking about executing your goals in war and an engagement, the money question kind of flies out the window. It's like, how do I get the capability? To some degree, if it's $1 billion, it's not tenable, and you could field 2 of them. But that's kind of what we look at. And so what we want to do is allow you to not have to care about the group 1, group 2 issue. If you have, I don't know, I forget off the top of my head how many tanks would be in a column, but let's say you have like 8 tanks that are in a line, and they want to be spread out, right? If every other one has an Archimedes system on it, that you can go and provide a bubble of defense for our own soldiers, for our own tanker crews. And you don't have to care about the group 1, group 2 issue. You can go execute the mission. You can go close in under your target. You can do whatever you need to do. And that's really what we want. We think that's incredibly important. And we think we can get a cost differentiated. We can get a cost differentiated way to deploy that, where it's not like $200 million, right? It's a lot less. And so from there, it becomes, we essentially just unlock your capability to actually go and execute your mission.
Ballpark figure how much, because we all hear about swarms, and you see the drone, the Guinness World Record drone swarms in China. It's almost like a Rorschach test. Do you see art, or do you see next gen military capabilities? Just give me a ballpark figure on how many drones one of your systems could shoot down in, I don't know, a minute or 2 or whatever, if possible.
I can't do it. I'm thinking about it. I'm like, nah, I don't think so. I think the way we think about it is, there's obviously some fundamental limit when you have a laser and you're going target to target. There's some fundamental limit to the number of drones you could take when you're coming in. We want to be small enough, lightweight enough, and reproducible enough, so like our cost comes down, so that if you are in an area where you're going to be engaging more, it's actually really easy to add another one or a third one, and these systems can coordinate fires. So that's how we think about it. Yeah.
Right. What benefits do lasers have over physical solution like bullets or something else?
Yeah, for sure. Well, number one, like our range. So you pretty easily get out to a 1, 2, 3 kilometer range on a relatively modestly powered laser, as long as your output aperture is big enough. And it's pretty apparent that drones, like there are some kinetic systems out there that use like machine guns. There's like the remote weapon system and everything. When you have a machine gun firing and you have a bullet drop of say 700, or you have a muzzle velocity of say 700 meters per second, and that system is firing at a drone that's say 2,000 meters away, you have like a 2 second time delay before you actually hit target, right? That's a lot. I think what you see is a lot of the remote weapon systems are targeting at like the sub 500 meter range, something around there, pretty accurately, but you do have to fire a spiral burst. That can get very expensive. You have to carry ammunition around with you. And so it's just something where, your because the ballistic trajectory because of the ballistic trajectory of the bullet as well. You have to have an extremely advanced control system. Part of what we can do here is like the laser is a stick. You just point and turn it on and you hit, and it moves the speed of light as fast as possible. When that is true, our control problem is easier to some degree. Now, we do have to stay on target, so there's some vibrational considerations. There's some precision considerations we have to take into account. But when you're using a firearm to shoot down a drone, you have to forward path plan in a very advanced way on like probabilistic frame horizons in the future, where that drone is going to be, what is its pose, how is it going to move in the future. That's extremely difficult, and I don't think scalable, really. I don't think that you want to do that. So I think we provide a very differentiated way to go and take down drones.
There's been all this talk about bits versus atoms and how, we've had this narrow kind of progress for 50 years. Talking to you and other entrepreneurs in the aerospace and defense industry, it seems like you're really approaching the problem on two fronts. It's really a whole lot of atoms innovation, but a whole lot of bits in there too with software. Just talk me through, how much innovation has gone on either of those sides for you guys.
Yeah, I mean, we do not... Our team is split about 50-50. I know that's not attractive or I know that's not as fun, but so we build our whole turret. We design the whole thing. We buy power systems, we buy subcomponents, we buy chips, we buy cameras, but we buy lasers right now, but we're modifying them, and then we'll go out and make our own here soon. So we do the vast majority of the hardware work on our side, but then we also write our own fire control and our own C2. We don't buy software from anyone. We write we use our own identifier. We train our own models. We collect terabytes of information to go and train models on for object identification, and like multimodal ID. So I don't know. I don't think I've thought about it too much. I would just say 50-50 split. If the question is how much are we investing in either one, because I think both of them kind of come together. Like if you do if you do controls dynamic modeling on any kind of dynamic system, you want an extremely well-defined hardware set in order to have an accurate controller. And then the utility of that controller to some degree depends on how accurate your sensors are, how high your rep rate is for sensing where, like, trying to understand in the state space where your controller is, where your system is. So I'm just rambling. It all comes together. I'm going to give you the boring answer. It all matters equally. It's probably true too. Yeah.
Yeah, it seems like in Ukraine, there's been this constant game of cat and mouse. It's like one side invents, one technology and they get ahead, and then, the other side invents a counter technology. The OODA loop is really, really fast. Mm-hmm. Do you think it's possible for anti-drone technology to get so good that it essentially eliminates the threat of drones on the battlefield?
Do I think it's possible? I'm going to express a very uneducated opinion. It's just vibes based.
Right.
During World War II and after, it was apparent we were kind of not only in the nuclear age, but an age in kind of the distributed force aircraft carrier, where really your capacity to go and have a mobile strike force wherever in the world, basically along the coasts, was like really a very ultimate expression of power. And we built a lot of our military around that to some degree. That's very reductive. But I think in some parts, we spent billions and billions of dollars on like 13 aircraft carriers, right? It was some of our biggest expenditures. And that is 80 years on, 70 years on. I think drones are probably like a 70, 80 year thing, where it's like a next massive revolution, right? It might be as important as the bullet, where it's like a 500-year kind of era-defining thing. I don't know, though. I don't know, because I think radio frequency was like the way to do it. That was very cheap and edge deployable to take down drones. And that is not working. You can put a Coral TPU and a Raspberry Pi into a drone, and then vibe code a terminal guidance system in like an afternoon, right? So it's like there's no signals to jam. So you need some way to hard take down the system. And those hard kills are much more difficult to deploy. You have to deploy a machine gun or a missile or another drone or a laser weapon, right? And that all those things are hard and expensive to go and deploy. Yeah, those are my thoughts.
Yeah, just speaking generally, how much power is needed for something like this? Because what I find fascinating is your ammunition is essentially electricity, right? So it's kind of like it's fascinating. Could again, but ballpark, could these things stay up for hours, days, or just talk me through maybe the different trade offs versus other Kinect systems?
Yeah, for sure. Well, we would be deploying mostly on vehicles and then in some cases in static installations. So in almost all of those cases, you actually have power available to you. You're on a truck or a tank, you're generating electricity from your alternator. It's not enough to power the system to go and be firing directly from vehicles in most cases. And so the way that we are looking at it is from an operational capacity, where when you're engaging in combat or like a drone swarm, it doesn't take place over the course of hours. It generally takes place over the course of minutes very quickly, and then you have downtime. And so we want to be ready to quick draw down a lot of power very quickly, but maybe not a large total amount, just like a high load for short periods of time. And then be able to go and recharge and either replace your battery system or recharge it with what you have available to you. We think that makes the most sense right now. Yet to be seen.
It seems like you guys are the first in America to do this, but where is China? Where are other nations in the kind of laser technology space right now?
For sure. There's some really cool companies. There's one that's a little bit older than us out of Australia called AIM Defense. They're very cool. They're a very, very cool company. I've chatted with the guy from AIM Defense very briefly over email. So we'll try and link up, I think. There is a French company, I believe, as well, that I don't think they're doing autonomy, but they're doing kind of like laser rifles in a way, which, by the way, laser rifle seems sicker than the laser turret, much easier. If there's a market for a laser rifle, I can make it like next week. It's actually very, very easy to do. But I think you're really shitty at aiming, though. Like you're just like wiggly human hands. Like you're not going to hit anything for long enough over like 50 meters, I think. But you could blind cameras in installations, so that might be the way to do it. But yeah, that's that. In the UK, they have, I think they're making Dragonfire laser systems for like 120 million pounds or something. I was reading each, so that's kind of, it's sick. It's cool. Don't get me wrong, but it's that's kind of not really in our space. And then there are Ukrainian and Russian options that have come out there. So, like necessity is incredible. It'll make you do crazy things. So like the Ukrainians and the Russians have deployed these laser weapons that are like smaller than they're like small. They have a lower power than ours. And they don't work as far of a distance, and they don't work very well at all, but they kind of work. And that's good enough for the Ukrainians sometimes. And they'll go and deploy them and try them out. And so they'll probably evolve that technology. So I think there are other countries that are doing what they need to for their own MODs. The way that the United States is going to work is like, we're not going to deploy something that works 20% of the time. We're not going to deploy like a radio frequency system that destroys all of the electronics, like in an EMP on a soldier, right? The soldier carries tens of thousands of dollars in electronics. So I think when you go out and do this, you can look at what other countries are doing, and we do, and it's really interesting. I think it's very clear that the bar is higher for the U.S. military, and so we need to go and answer that.
Yeah, maybe allow me to ask a dumb question. Could these laser guns, laser turrets harm humans, or is it only, drones and airplanes and stuff?
Yeah, so we essentially, the number one thing that you want to do is just never fire at a human, and so that comes down to like a safety and AI controls. AI and controls kind of problem, where you really are only you essentially are training on the data of things that you want to shoot and things that you absolutely cannot shoot, like humans or objects that might have humans in them or have humans near them. You apply kind of an inverse weighting where you're like, definitely do not shoot anywhere near there. So that's number one. The number one thing is never to shoot at a human. The second one is that, there is kind of there's kind of a, if you are not being fired at, like you'll be fine, essentially. If these lasers, it's like a bullet. Like if you're at the pointy end of a stick of a bullet and the gun fires, you're going to be in trouble. So we would have a very, very similar, I'd say, safety operational, like book on safety on how you kind of deal with these and what is the operational capacity for using these in the field to a machine gun and training associated with it as well. That'd be the best way to do it. But these systems will never be used to kill humans. You have way too much water in you. It's gonna are you gonna wait to burn a hole in you for 2 minutes or something? Or are you just gonna use the thing that there are millions of all over the place in the military, which is like an actual gun where the gun's been developed for 500 years to kill humans? It's like an evolutionarily optimized thing to kill humans. So you probably wouldn't replace it.
Talk me through the commercial applications of this technology. It seems like I think we both got to meet Arthur Herman, the author of Freedom's Forge, last week. And one of the things I really took from that book was how World War II was won by this fusion between civil companies and military companies. So, General Mills, they made Cheerios in the morning and Scopes at night. So, yeah, just talk me through the commercial applications of the technology.
Yeah, for sure. I think a lot of it has to do with laser systems that we're developing. There are only a couple U.S. laser companies now. One I used to work for, the bottom end of our product lines would get killed by China every 5 years. The Chinese were able to procure some technology, I believe, 15 years ago, out of the fiber draw towers at Coherent, and I think another company, where it went back to China, and now there's 7 Chinese fiber laser producers. So I think what we'll do is we'll be the first totally US-based laser producer to be stood up in a while. There are some shops that are around, but no one really produces things at scale other than 2 or 3 companies. And if you look at the optics supply chain in the US, it's crazy. There's maybe 1 or 2 companies that do everything across the board. So you have to mine rare earth materials. You have to actually kind of extract them and refine them. You have to go and cut dies, or you have to go and cast dies. You have to then cut in a very advanced way if you want to do any kind of annealing, cutting, welding, everything like that. Say glasses, for example, you need lenses, you need mirrors that are very, very high fidelity. You need capital equipment that is kind of like ASML type semiconductor equipment to go and do that. So barely anyone does this stuff. And if they do, they need to get volume on something. So if you buy glass lenses, for example, in the United States, and you want to buy them from a mass producer like a Thor Labs or an Edmund Optics, and you can buy 1-inch circles. You can buy 1/2 inch, 1 inch, and 2 inch circles. Generally, some things are 3-inch circles. For say high power laser light, like near IR fiber laser light. The 2-inch one could be $700, $800, $900, something like that. And then if you want to go to a 4-inch or any kind of other shape than a circle, it's $5,000 immediately, because you're talking about retooling an ASML type tool. So it's just the supply chain is extremely, extremely weak across the board. We're not going to tackle all of it, but what we can do is we can go and stand up a producer of laser systems and provide them in an area where the market growth is 10% per year. It's grown by 10% per year on average for 40 years, nonstop. Just massive market for especially cutting and annealing material processing laser systems.
This technology sounds very futuristic, but I know you've had some successful live fire tests. Tell us what you can about those tests, what you've already demonstrated in the real world.
Yeah, for sure. I mentioned it a little bit earlier. We have I'm not going to say the ranges, but we have probably 4 stages of development for shooting that we want to show. We're finishing up kind of the second stage where we want to go from a very short range to a very medium range of shooting, and we should be done with the final distance and fidelity of the system by the end of the year. And from there, we'll be ready to produce, do some DFM, get into manufacturing, which is always a joy. So yeah.
Welcome to manufacturing hell, huh? This is obviously an autonomous system that you're building. Do you think the future of the battlefield, in 5 years or even less, is fully autonomous? Do you think that's where we're going?
I actually agree when military officials, especially in the U.S., say, you always will need boots on the ground. You always will need boots on the ground. You need someone to take ground and hold ground. You need, like, what is the point of what is the point of having machines just like hold ground? So I think, does everything become autonomous? I think a lot of it does become autonomous. It's apparent that the offensive capabilities of drones are part of the reason why they're so effective is because they're semi-autonomous. They're using a lot of like target identification and tracking techniques that are really, really advanced, and it's not that hard to put a logic path planning on it to do everything autonomously. So that's pretty clear to me. I think that it becomes probably mostly autonomous. Yeah, probably not a very exciting answer, but yeah, probably mostly autonomous. But I think you always need like Green Berets and SEALs to go hold stuff.
Drones, it amazes me how fringe they still seem to some people. Do you foresee, a world in the near future where the drones aren't just used on battlefields, or anti-drone systems like yours aren't just used on battlefields, but they're common sights at, every presidential rally, every Super Bowl, every major concert?
Yeah, almost certainly. I think just because of how easy it would be to cause a lot of devastation on the homeland with a drone, we should probably prepare for it to happen. We should probably just presume that it's going to happen. And so I think what you need some way, in the least disruptive way possible, to actually get hard kills on drones in a civilian setting. My bid would be on the laser, but I think there are a few different ways that you could do it. You could probably use a radio frequency method if the problem is it's so easy to terminally guide the drone also, so that wouldn't do anything. If you use a directed energy system, you're silent and invisible. And if you were above, like if you're on the top of a stadium or an embassy, for example, you could be relatively non-disruptive. You can tune your wavelength and your pulse parameter to be very lethal at a short period, and then very, very quickly kind of cubically dissipate your power density. And so you're very, very, and absorb in glass. So if anyone in a building would be safe, everything like that. So there are ways to mitigate, to kind of deconflict the issues there. Yeah.
What's one fact either about lasers or defense tech that you think would genuinely shock people if they knew it?
A mirror does not work. If a mirror would reflect the laser, my system would be much, much cheaper, because you use some mirrors and lenses to do some modification on the beam, and you have to expand your beam to get the power density down so it doesn't destroy mirrors, and it still destroys mirrors. And so when you're focused on something, it's annihilated pretty quickly. So when I was raising our second capital round, I did like a 9-page write-up on the physics and the cost to what you would have to do to a drone to defend it against several kilowatts per square centimeter of laser light, near IR laser light, and it's very expensive and bespoke. It's not impossible, but if an enemy drone, instead of $1,000, has to cost $300,000 to defend itself again, and weigh 5 times as much to defend itself against a laser, that's a win. That makes those drones not mass producible. So that's what we look at. But I do have a meeting in a minute, so I gotta go. But yeah, anything else?
Yeah, can we do a rapid fire round of overrated, underrated?
Okay,
I'll take 1 minute of your time.
Let's go.
All right, swarms.
Correctly rated.
Subsea drones.
Underrated.
Space weapons.
Underrated.
Electronic warfare.
Overrated.
Iron Dome.
Like Israel's Iron Dome. I think correctly rated.
The Golden Dome.
The hype is so high, but I think still underrated.
Microwave weapons.
I don't want to talk my book. I think probably correctly rated. Yeah.
Loitering munitions.
Accurately rated. I think people are properly freaked out.
Anti-drone turrets.
I think correctly rated.
And last one, fixed wing drones.
Overrated.
Michael, thank you so much for your time. Tell people where they can find out more about what you guys are doing.
Yeah, for sure. You can check us out on aureliasystems.com, where we have our website. If you want to reach out, just DM me on X at LaFrogman, or on LinkedIn. We're pretty active. And yeah, come chat with me about laser systems. We're hiring a bunch right now. We just finished a capital round. So yeah, would love to chat.
Well, Michael, thank you so much for your time. I'm looking forward to seeing you next time I'm in San Francisco in November, and we'll chat soon.
Yes, sir. We'll chat soon. Thank you so much, brother.